recording of the sessions. Yep. Okay. Okay, we will see what Apache Hadoop is and just a basic introduction to Hadoop concepts and components inside a Hadoop ecosystem today as part of this demo. So the main agenda of this demo is like I will give my introduction. After that, we will see what is big data and about Hadoop history and the basic Hadoop cluster architecture and HDFS. And if time permits, we will also see some of the HDFS concepts related to blocks replication, rack awareness and all. If this, I will cover only if the time permits. Otherwise, I will just give you what is big data, Hadoop history, and basic HDFS cluster and the components inside your overall Hadoop architecture. Okay, so this is myself, Sivakumar. You might have heard of my name, and I have around total 7 years of experience in IT. It's a close to 7 years, and my relevant experience on Hadoop is 3.5 years. And I have experience on various Hadoop distributions like Apache Hadoop and Cloudera Hadoop and Hortonworks Hadoop as well. So these are Cloudera and Hortonworks are like a commercial vendors for Hadoop. Okay, so we will come to know even those things also. And I used to maintain, I'm maintaining one technical blog on Hadoop, which is hadooptutorial.info. And I have exposure in various domains like banking, insurance, and storage devices. And these are some of the tools that I have a technical strength in Hadoop ecosystem. These are only inside Hadoop. Okay. So, and I have experience of almost like 1.5 years of experience in training Hadoop batches. Till now, I have covered almost like 9 training batches. Yeah, the Pranav was one of my previous batchmate. Previous, not previous one. Okay. So before going into what is Hadoop, let us see one of these famous buzzword that we hear very frequently in the industry, in any organization. This is the buzzword that we always hear about: big data, big data. Okay, so what is big data? So the definition for big data will vary by the person who asks you. Okay, based on context, I can define it like the data which cannot be processed by the existing tools, which cannot be stored or processed by using the existing available conventional tools. Okay, any of the traditional RDBMSs, Oracle, Teradata, MS SQL Server, or any other softwares that we have. Okay, and generally, as of now, the big data terminologies that we consider as, like, if you have data in terms of TBs, in terms of terabytes, it could be 5 terabytes or 10 terabytes or even 50 or 100. If you have data size in terms of terabytes, then we normally treat that as a big data. If something that is less than a TB, we don't really call it as a big data when we talk in terms of size. Okay, but that convention or that tradition may not continue forever, because today's big data may become tomorrow's small data. and tomorrow's big data may become small data for day after tomorrow. And these are some of the measurements that we frequently come across when we talk about the big data sizes. Okay, so 1000 GB equal to 1 TB. This anyway you might have already idea. And 1000 terabytes is 1 petabyte, and 1000 petabytes are like 1 exabyte. So this 1 exabyte is something like 10 to the power of 18 bytes. Okay. Hey, sorry guys, I live nearby a railway track. Okay, my apartment is close to some of this railway track here. Sometimes you have to bear with me this train sounds. Okay, especially during this my morning times, these trains come very frequently. Okay, but may not be that much disturbing. Once you enter into the subject, I don't think it will disturb your concentration. Okay. So, and 1000 exabytes are equal to 1 zettabyte, and 1000 zettabytes are equal to 1 yottabyte. Okay. So when we talk this big data, so you may get doubt, why is it so big? Okay. The reason is the growth rate of data every day that is adding up into any of the organization. Every day, I mean, there is a one IDC which collects. IDC is nothing but International Data Center, which is an organization or firm which keeps collecting the information across the globe every year and every quarter, and it has its own statistics and its own collections, how fast the data is growing, and how much each organization is producing the data, and how much each organization is spending, how much amount of money they are spending on to process this data, and all related to data all over the globe. This IDC is used to collect all these metrics. Okay, so as per the IDC's predictions, the total global digital data as of 2013 was a 4.4 zettabytes. So as I said, 1 zettabyte is equal to 10 to the power of 21 bytes. Okay, so that is so big, you cannot even imagine. If I give you one simple example, if you write that entire 4.4 zettabytes of data into separate DVDs, each DVD will be around like 4 GB, right? 4 GB or something. If you write them into DVDs and if you put them in a stack, if you pile them onto a stack, and if you start piling them from Earth, it will reach until Moon. So then you can imagine how big the data size is. And even if you know, I can say it like if you want to store the entire global's digitalized data at one place, you need almost like a one state, almost. I mean, there was one of the example there. You need cities like a New York, almost like a 5 to 6 cities are needed. That much area of space is needed to store all these servers. Okay, since anyway these data centers are also distributed across the globe, that's why we don't see it like the centrally located area that much needed for storing this data. Okay, and one of the reason why this data is coming this much is like the growth rate. Every day, earlier 5 years back, we only had a few. The data was like in terms of petabytes. So every year after the social media sites and the lot of mobile apps, and the so many websites that are generating the lot of uh, publications, articles, or something, and there are a lot of digitalized applications. Even if you buy any insurance or if you make any banking transaction, everything is causing a digitalized transaction. So which is getting stored somewhere and which is processed by someone. So that is causing the data to be stored on computers. So it could, some of the examples are like a weather information collection and social media sites, Facebook, LinkedIn, Twitter, all these sites. And the photos we upload, the videos, the audio recordings that we upload, and any transactions that we do, and any cell phone apps and websites, all these constitute towards the big data. And almost like 90% of the data that we have currently in the world is just generated in the last 2 years. Okay, so then you can imagine how big, I mean, how fast the data is getting digitized. And it is expected that every 2 years, the data will get doubled in the computers, and it will become 44 zettabytes by 2020. These are some of the predictions by IDC. So this is just to give you just that. So there is a lot of huge data available in the globe, and which is not able to processed by any of the existing normal tools. Okay, and the average cost to store this 1 terabyte of data is around like a $3,000 per an organization. This is just for storage, not for processing. Okay, and for processing that 1 GB of data by any organization, it's costing around $18,000. Okay, and the number of companies that are expected to have 1 petabyte of data by 2020 are like 1 lakh companies are going to have at least 1 petabyte of data. So then you can imagine, so what is the need, I mean, how much the need for big data tools by 2020. And even you don't know, I mean, you might not be having idea, you might not even have heard of what is Hadoop 2 years, 3 years back. But I can see how drastically it got popular and it got it famous. So even small organizations, just with 10 employees, 20 employees also, they are also started exploring what is Hadoop. How do we can compete with it? Okay, and there are various characteristics of it, why it becomes so popular. We will come to that in the next slides. Okay, so before going to there, so yeah, if the big data is so big, and what are the other characteristics for it? Okay, one is anyway its volume, because when we talk about data in terms of terabytes, petabytes, or something, so the volume of data that needs to be handled is very huge. Okay, so that hugeness is one character, and the second V is velocity, the growth rate, how fast the data is getting produced. Okay, so as I said, every 2 years the data is getting doubled across the globe. And the third V is like variety. What are the different various types of data? There are mainly 3 types of data that we deal with in big data. So that I will cover in the next slide. Yeah, when we talk about the characteristics of big data, we mainly specify this big data characteristics with these 3 V's. Okay, volume, velocity, and variety. And sometimes, very rarely, we also name these 2 V's as well. One is a veracity, and the fifth one is a value. Veracity is nothing but how accuracy or how meaningful your data is. Okay, sometimes you might be dumping all the data. I mean, it's like a dump yard, but out of which 90 to 95% of the data might be useless. You might not be willing to even revisit the data. Okay, so even that we consider into big data only. Whatever data that we generate, so that is considered as part of big data only. And the value, we talk the big data in terms of value as well. How much valuable, how much add-on it can give to any organization, how much it is useful for the organization. Okay, yeah, so if you see the three different fronts for the big data, so the first one is a volume. From few years back, so when we talk about data, we were specifying that in terms of MBs. Later it went into GBs, and now we are in a TBs phase most of the time. Okay, so currently we are in a TBs phase. In next layer we will enter into petabytes, and yeah, this you can treat this as the outer layer is having only 1% of the organizations are into this outer layer, and remaining majority of the 90 to 95% of the organizations are within this layer. Okay, so which is in terms of storage in TBs. And if you talk about varieties of data that handle, so the tables and databases, and sometimes some kind of photos and some websites information, weblogs and audio recordings and all. And if you talk about data velocity, earlier we were getting the data in terms of batches. Maybe every 24 hours we might be getting 2 files, 3 files or something like that. But later it got increased to at every periodic intervals, something like every 6 hours or every 4 hours we used to get some files. Now near real time means as soon as the data is generated by the source machine, you are getting the data within a 10 or 15 minutes. If you get the data within a 10 or 15 minutes of data generation, then we call it as a near real-time data storing. Okay, so the actual real-time is as soon as you enter something on your front-end screen, if it gets stored and if it gets processed, that is something real-time processing. Okay, and the outer layer, yeah, if you talk about the data varieties of here, we consider the social media data. Either it could be Facebook or Twitter tweets. As soon as you type something, so there are some clients that use Twitter data directly, and they process your tweets, and they will analyze what type of categories of goods that you are interested in, and what type of your most favorite interests are like. So what are you interested in? So those guys analyze by your tweets, and they will keep suggesting you that kind of products. Suppose if you are interested in any watching movies or something, they will keep giving you ads on the on your profile pages. They will suggesting you some trailers of movies. Or if you are interested in any mobiles or something, if you talk about in your tweets, if you talk about any mobile apps or something, they will keep suggesting you some electronic goods. If you talk about any clothes or something, and they will appropriately suggest you such kinds of goods on these popular websites, something like Amazon, Flipkart or Facebook. Based on your interest, they will keep posting you the appropriate tools. So how does they do? Okay, so they will track all your web clicks and all your tweets and all your information. On the other front, it is some kind of a privacy breach. So whatever you type, that will get processed and that will get analyzed, and appropriately you will get suggestions. And yeah, these three are three V's are some of the characteristics for big data. And by analyzing the big data, so you will get some kind of recommendations, and you can track the history of an organization, where it is going. Suppose one company might be dealing with a different kinds of products. Okay, out of which all the customers might be focusing only on a particular category of products. Okay, so that he can analyze based on looking at the history records, and on that area he can better invest so that he to expect the better revenues. And also on the other side, he can spend some time to analyze what is wrong with the other categories and how can he improve. Okay, so these are some of the real-time scenarios. And if we talk about the three different types of data, so mainly in any organization, you will definitely find the structured data. Structured data is nothing but the data that is stored in a rows and columns format. There you will have fixed number of columns. Okay, so and each column will have a separate data type for it. Suppose if you define a name, it will be of string, and if you define a salary, it will be of a double. If you define an age, it will be of integer. Yeah, that way you will have a columns defined and their data types defined. Here are some of those examples, and there are some data sets which are of semi-structured. Semi-structured as in the sense, I think you might guys have an idea of what XML file looks like. And XML files will have mainly tags. Inside the tags, we will store the data. Tags are like just a keywords, and the text is like a value for keywords. And the same case with the JSON file formats as well. And we will see how to process these XML files and JSON files inside Hadoop. Okay, so when we actually start with the our training. And the log messages and log files that are generated by web servers, even they will have, they might not have exact separation of the columns, but by applying some offset based extraction, you can make them as structured. Okay, all these semi-structured data sets, they are not, they cannot straightly stored in any database straight away, but after applying some parsing techniques and after making only the useful information and useful columns from them, you can finally store them into any typical databases. Okay, so there is a third category of data which is very huge in size. This is unstructured data. These data sets may lack structure. The entire data set may lack structure, or a part of the data set lack the structure. Only a part of data set might be lacking the structure. Some few of the examples are like your email message, your emails. They will have some kind of template. They will have a to address and CC address and from address, subject and body. On high level, if you talk, you have 5 attributes, but inside body, you don't know how your data is organized. And even the same case with the subject. You cannot break them or parse that data. Okay, so there it's like a part of the data is unstructured. And the same way, videos and photos, audios that upload into any sites are like some of the examples for completely unstructured data sets. Photos and audio videos are completely unstructured, and emails and free form text, and these are some kinds of data sets where you can have a few columns you can easily identify, and the other few columns you cannot exactly parse or do any useful analysis on top of it unless until you make them structured. Okay, so this videos, photos and audios, this is still some area where even Hadoop or big data has to innovate things to better optimize it. Okay, And as per the experts' estimation, across the globe, around 80% of the data is unstructured data only. Only 10 to 20% of the data is in structured format, and all the organizations are dealing with only that 10 to 20%. Yeah. So yeah, that's where these organizations are thinking that just by processing the 10 to 20% of the data, we are able to generate this much of revenues. What if we find a solution to process this 80% of the unstructured data? So then there is a huge growth rate in revenue for the organization as well. All the organizations slowly started thinking in that way, and they are exploring the tools to process this unstructured data as well. Okay. Those three categories of the different varieties of the big data. Okay, when you say it's a big data, you should assume it like it's a combination of structured, semi-structured, and unstructured. You can receive any type of data set. Okay. Now, next we will see what are the challenges for processing the big data. What are the challenges with big data? One challenge is that we talked just now. It's a complexity and different varieties of data types. Because if you have a tables, you can store them in RDBMS. If you have XML files, you should have another storage mechanism. You cannot store into RDBMS, XML file or JSON file or log file. Okay, so you should go with other storage mechanism there. So the complexity and variety of data types is a first challenge. And the second one is in terms of volume. Disk storage. If your data size is 1 TB or 100 TB, so then you cannot store them in a typical databases. Your typical databases, Oracle or Teradata or something, these have limitations up to some TBs, maybe 5 TB, at max 10 TBs of data. And even with the 10 TB of data, so to process them, it will take a lot of time, maybe sometimes in hours as well. If you have to process 5 TB of data, it will take around 2 to 3 hours, or sometimes if your RDBMS is not completely fine-tuned, so then it may take more than 3-4 hours as well. Okay, so the disk storage and transmission capacities of the machines is one of the second challenge. The third one is access, utilization, and update. How to access? If that is so huge, if you are storing 5 TB of data in Oracle, then if you want to just to retrieve one single record, sometimes it will take in minutes. Okay, and if you reach a certain if you reach beyond a limit of storage, threshold storage, then it will not even respond you. It will stop responding for your queries. Those are some of the challenges that with the existing traditional tools to process this big data. And those are the three key challenges here. And in any big data processing, these are some operations that gets involved. Okay, so if you are generating huge data, there should be a mechanism to collect it. Okay, you have any question? Giri, you joined just now?
Yeah, hi.
Okay.
Hello.
Yeah, yes, Giri. We are in the middle of the session.
Okay.
Okay.
Yeah.
I mean, if you are interested, I will share the video recording as well after the session completes. Okay. Okay. So the first step when we are dealing with the data, any data, the data collection, and once you collect the data, you have to organize it in a proper manner so that structured data goes into one separate system or something, and the unstructured data will be stored in some other area, and semi-structured data will be stored in some other area, and intermediate data will be stored in some other area, like that. Okay, once you organize and make it structure, we will try to we will try to structure it, and after that we will get some statistical analysis, statistics about the data and summarization. Okay, suppose you collect the data about 1,000 employees. You might be collecting the data from each employee at employee level, and if you summarize them, we talk about what is the average salary for all the employees, and which departments are performing well and which departments are not performing well. This kind of summarization also you will prepare, and we will analyze that data. Okay, what are all the departments that are performing good, and what are all not doing good, and finally we will make decisions on top of that.
Shiva? Hello, Shiva?
Yes, Vijay.
Yeah, Shiva, there is a issue with the connectivity of the audio because I'm unable to hear you in the mid, sometimes I'm losing the connection.
Oh,
Just,
okay.
The conversation.
Okay, might be I might have, maybe because of our network, sometimes the voice might get dragged. Okay.
Okay, no problem.
Yeah. Okay, these are the typical operations that gets involved in any of the data processing: collection, organizing, summarizing, analyzing, and finally decision making. Okay, so how does Apache Hadoop helps in all these operations? Okay, we will see what is Hadoop. Parthiban, do you have any question? Parthiban?
Yeah.
Do you have any question?
No, sir. We continue.
Okay, then I will mute you. Okay.
Okay.
So Apache Hadoop is an open source framework. Okay, whoever are from non-Java background, they might not have an exposure to what is open source. Okay, I will try to explain you what it is. Okay, from definition perspective, it's an open source framework for managing, for mainly storing and processing huge volumes of data. Huge as in the sense, at present we talk huge in terms of terabytes and petabytes. Okay, and I doubt whether there are any organizations which are handling data in terms of exabytes. There are no, because the entire global data size itself is 4.4, might be around 6 exabytes by now. Okay, so as of now, all the data that is getting handled inside a Hadoop cluster is at max in terms of petabytes. Okay, so here the open source framework what means, yeah, it is a software or source code that is made it open for everybody. That made open for everybody. Everybody can download it and they can modify it and they can use it for their own purpose. Or without even modifying, they can straight away simply use that as it is. Okay, and they are given a freedom that they can download the source code and modify it, and they can give their own name to that, and they can even publish and make it again open. Okay, but the restriction is they should not sell that software or framework. Framework is nothing but a collection of different Java classes, or any, I mean, it's just a collection of some different components which will do some kind of backend operations for you. Okay, and some of the important characteristics that make Hadoop as a more popular in the industry are here. So these characteristics, mainly if we talk its ability of distributed storage. Suppose you have a 10 TB of data and you have a desktop with a 500 GB. Anyway, you cannot store that entire 10 TB into, or let's take, for simplicity, let's take only 1 TB of data is there, and you have a 500 GB hard disk with you in your laptop. You cannot anyway store in one single machine. In the same case, even if you take a large servers, if your server capacity is like 10 TB, and if you have 20 TB of data, you cannot store that 20 TB in one single server. And the conventional approach was like, if you are not able to store something into 10 TB machine, in all the traditional approach was like, replace that 10 TB server with a 20 TB server. Okay, so anyway, they are again going to replace one single machine with only one machine again, but this time with a more powerful configuration from processing perspective as well as the storage perspective. But there is a limitation for that approach, so that we call it as a scale up approach. If you are not sufficient with a 1 TB storage, if you replace 1 TB server with a 2 TB server, that we call as a scale up approach. But Hadoop follows scale out approach. That means you cut your data into different parts and you store them on a different machines. You distribute the data. Scale out. Okay, you don't need to increase your processing capacity and storage capacity within one single machine. You can combine, you can join, you can network multiple machines together, and you can form as a cluster. Okay, and the cluster is one of the keyword that you frequently hear in a Hadoop terminology. Cluster is nothing but a combination or a network of machines. Suppose you have a 10 desktops. If you connect them through a network, so that every machine can access the other machine storage and all RAM, CPU, and everything. In that case, that is called as that entire 10 machines network is called as a cluster. Okay, so here, yeah, the distributed storage. If I talk about distributed storage, if you have 1 TB of data and you have 4 machines connected in a cluster, then you can assume it like 250 GB of space is stored on each machine, on each of those 4 machines, finally contributing to 1 TB of storage capacity in total. Okay, it's not a straight away equal formula. There is some backend procedure that we will cover in the actual session. Okay, what is the logic it follows to split that 1 TB of data equally across all the machines? Okay, how does it splits that into equal parts? And the second characteristics which made it very powerful is a parallel processing. Okay, so if you have a 1 TB of data on 4 machines, and instead of having one single CPU and a RAM allocated for entire 1 TB, if you have 4 CPUs and 4 RAMs, and all of them started simultaneously processing 250 GB of each storage, then you will get results even more faster. And that is the second more powerful characteristics of Hadoop, which made it more powerful than any other existing tools. Okay, and the third characteristic is that it's a free open source, so that any organization or any individual can download and can use. Okay, and the fourth one is it runs on commodity hardware. Even on normal desktops, normal laptops with 8 GB or 4 GB RAMs, then on them you can run this. Okay, you don't need a fancy servers, which like a 5 TB terabyte storage and 128 or 256. I mean, you don't need some terabyte of RAM or 10 terabytes of storage. Some kind of such a fancy huge hardware is not needed, because if you talk about cost, the 4 GB RAM will cost you around 2000 rupees. But if you take 8 GB, it is around like a 6,000 or close to, close to 6,000. It's not double. When the storage, when the RAM capacity is double, the cost is not getting double. It's exponentially getting increased. If you take about 16 GB, it will cost you around 12 to 15,000. The same way. If you take it proportionally, the 4 into 4, 16 GB should cost you only 8,000. But if you want only one single RAM with a 16 GB capacity, it will again cost you around 15 to 16K, not just 8,000. So when after certain limit, if you want to upgrade your hardware, the cost of hardware will be, very huge, very high. So that's where the Hadoop framework guys came with the ability to run on commodity hardware as well. And the fifth concept is something like a data locality optimization. In conventional DBs, RDBs, suppose you have a 1 TB of data table and you are running a select query on top of it. And that in the better case, assume it like even that 1 TB of data is distributed on different storage servers, and you have a computing server. And in the existing systems, you will have a storage server and computing server kind of framework. If you run a query, they used to bring the data to the computing server. So suppose out of that 1 TB storage, you are accessing a table with a 1 GB size. Then the conventional process was like bring that 1 GB data set into the RAM space of the computing node, computing server, and then do some computations and get the results and send them back to client. Okay, so that was the approach that was being taken care there. But in Hadoop, we don't bring the code to the computing server, but we bring the computing resources to the data where exactly your table resides. Okay, instead of moving the data, we move CPU and RAM to the place where your table is residing, and we move our code also to your data. Because if you take the size of data, it might be 1 GB, but if you take the size of code, your select query, it might not be more than 1 KB. Okay, moving 1 KB of data will be faster than moving 1 GB of data to this end. Okay, so that concept of moving the code to the data for processing instead of bringing the data to the code is called as a data locality optimization. And these are all the characteristics of Hadoop. Okay, and mainly here Apache Hadoop is a free open source framework, and there are some commercial vendors also for Hadoop. These commercial vendors, one of the popular one is a Cloudera, and whoever searches on Hadoop keyword, they will definitely get this banner published in somewhere in ad places on their web pages. Okay, and the next most popular thing, and this is more of like Indian engineers are there. Many Indian engineers are there in Hortonworks. Okay, and that's why some of the tools inside the Hortonworks Hadoop, they resemble Indian Sanskrit keywords, Sanskrit or Hindi keywords. Okay, something like there is a keyword called Ambari, tool name called Ambari. Ambari means in the Indian Sanskrit, it means the rider of elephant. And the same meaning given in inside Hortonworks as well. Who manages Hadoop? The tool that manages Hadoop is called Ambari. and there is a framework called Tej as well. Tej is for, in Hindi it is for speed, right? So we have that tool called Tej also to improve the speed. Okay, so majority of the Indian engineers are there in Hortonworks. Okay, I can say it like a majority of the Hortonworks is controlled by Indian engineers. And the other distributions, popular ones are like a Pivotal HT and Amazon Web Services. From Amazon Web Services also is there, and IBM InfoSphere Big Insights and Intel HD, and you also see Mapr Hadoop also there, and you also have a Hadoop from Microsoft. Okay, HD Insights, we call it as a HD Insights, and there are some others vendors also. Everybody is free to take Apache Hadoop, and they can put their own modifications on top of it. Okay, and they can release their own versions, but they have to give it on free. Okay, then how does these guys are making money? Okay, if these guys are making money by providing support for you. Apache Hadoop will also give you software, but you have to install it on your own. And if something goes down, if any of those services goes down, you only have to fix it on your own, and the risk is there from your end itself. You have to bear that risk. But these all commercial vendors, they will also give you the software for free, but they will take the risk on their shoulders. If something goes down, their engineers, support engineers will come to you within 1 hour or 24 hours. They will come and fix those problems for you. That's what the beauty of this commercial support. And especially the Cloudera engineers, you will definitely get within 24 hours. And even I saw the same thing from Hortonworks as well. If you raise any issue, even if you, if you are, all the clients might not be very strong in technical, right? So those guys, whenever one of those services present in the Hadoop ecosystem goes down, they will get immediate response and immediate support from these vendors. That's where these guys are getting more popular, more and more. Yeah, let's see, where does the Hadoop came from? Okay, as you know, for many of the tools, Google is the source. Google's white papers are the source for many of the popular tools in the IT industry. The same way, a few years back, around like 10 years back, Google published a white paper on GFS. Okay, it's a Google file system to store these terabytes of data. In IT industry, whatever the problem that comes, that should be faced by Google first, because it is one of the very largest organization. Because when somebody else faces this big data, Google had to face this at the beginning. So that time nobody else knows that keywords also. So that time they published this GFS, Google File System concept. Based on that, Yahoo took that idea and they implemented it, and they have given us a framework called HDFS. HDFS is nothing but Hadoop Distributed File System. So this HDFS is only for storing. Okay, so this is to store huge, large volumes of data set on the Hadoop. It will not process. There is another framework called a MapReduce to process this huge data. Okay, so the name MapReduce itself is having two keywords, map and reduce. So it will copy, or it will process a data at different locations, and it will combine those results, and it will produce a reduced output, and finally it will give you the a summarization output. Even this framework is built based on the MapReduce white papers that were published by Google, and even this was contributed to Apache Software Foundation, which is an open source community from Yahoo only. And the third one, HBase, even this is built on notion of Bigtable, and even this is done by Yahoo only. But finally, Yahoo contributed all these tools to Apache Software Foundation. From there onwards, Apache took them, and Apache allocated some engineers and committers to contribute towards these tools. And almost all these tools become top-level projects. Top-level projects as in the sense stable versions, stable releases were happened around 2009 and 2010. Okay, so almost like only 5 years. So the stable releases started releasing, stable versions of these tools getting released. Okay, yeah. So on high level, more or less, we talked about why we need Hadoop also, and this is one of the use case. It can give you very clear understanding why do you need to go with the Hadoop. Okay, when you have a single server and entire 1 TB is stored on this single server, single machine, and a machine, there are the hardware restrictions. This machine can have a maximum of 4 input channels, and each channel has a capacity of 100 Mbps. Means 100 MB, it can read 100 MB of data per second. Okay, and suppose you have a cluster of 10 machines. Okay, and each machine is having 4 input channels, and each channel is having 100 Mbps. So that means in 1 second, if you have this cluster, you can read here in 1 second you can read 400 MB, right? So each channel is 100 MB, and 4 input channels you have, it will take 400 MB. It will read 400 MB per second. But here it will read 400 MB into 10. So that means almost like a 4 GB. It can read 4 GB per second. It can only read 400 MB per second. When you have to read 1 TB of entire data that is stored in this machine and in this 10 machines, it will take 45 minutes in one single server, and it will only require 4.5 minutes to 10 machines. Then you can feel the power of parallel processing. Okay, so that's where everybody is moving towards the parallel processing concepts. Okay, so inside Hadoop architecture, now let's jump into Hadoop architecture. Now we have learned, we have discussed about what is big data and what are the characteristics of big data and what are the challenges with the big data and what is Apache Hadoop and some of the commercial Hadoop distributions, and why do we need to start with the Hadoop. Okay, so do you have any questions till now? If you are silent, I assume it like you are clear. And I will continue. Okay, yep. So let me jump into the architecture of Hadoop. It's not a completely clear architecture. I will just give you the vague idea what are all the services that will be present inside a Hadoop. Okay, so there will be mainly the core daemons. Core daemons will be 5. Daemon as in the sense, which is a service which keeps running continuously in the backend. Daemon is nothing but any Unix service or Java service that keeps running in the backend continuously until you stop it. Okay, and here the Hadoop architecture is like a master-slave architecture. Suppose you have 100 machines connected, you should have a master. You should have a master to manage them. Otherwise, who will provide instructions to all of these slave machines, right? So because of that, this is implemented in a master-slave architecture. Here, the master services are like, so this is a king. I represented it as a king, and the master services inside Hadoop are like a name node, which is related to, which takes care of all the storage requests. Okay, all file system related requests. And resource manager is another master that is part of our Hadoop architecture, which takes the request for processing your data. The name node is for, name node handles the storage requests, file system related requests, and the resource manager handles the processing requests. Suppose you want to search anything on 1 TB of data. So then you have to send a request or send a query to your resource manager. Suppose you want to store your 1 TB of data on HDFS, then you have to send request to name node. Okay, so that's how these two differ. And the slave machines are like these are slaves. They will have the counterparts on them. The storage, from storage perspective, we call it as a data node. And when it is processing that some data, then we call it as a node manager. But most of the time, these two services run on a single slave machine. Okay, on every single slave machine, these two services will be running on combinedly. But when we see this masters, you will have a dedicated machine for name node and a dedicated separate machine for a resource manager. But these two services can be combined together in one single machine. Okay, such slave machines can be multiple, any number. It can be hundreds, thousands also. 4,000 nodes also you can connect in a cluster. And there is one more service that is needed for support of name node, which is nothing but secondary name node. It provides the support for primary name node. Anyway, we will discuss the in-depth details about all these services. Don't assume it like this is what we will cover for these components. I'm just trying to giving you these terminologies inside this architecture. That's it, as part of this demo. Okay, so the next, yeah, so these will get connected. The master is name node, and the data nodes here in this sample layout, I have 3 data nodes and all connected to name node. And these, as I said, the node managers will also run inside the same machine, same slave machine. This NM is nothing but node manager. These will get connected to resource managers. Okay, so this NM services will controlled by this resource manager RM. Okay, so there are some other terminologies, fs image and edit log, which are controlled by name node. Okay, these two components, these are just nothing but the fs image is nothing but a simple file, is a binary file, and edit log is another binary file. These two files are controlled and maintained by name node. Okay, to support these operations in the backend, we have another component called secondary name node. Okay, so I will anyway give you the in-depth details about and roles and responsibilities of each of these components again in our practical sessions. Okay, so this is how the master slave architecture looks like on high level. Okay, And this is the HDFS architecture, right? So apart from HDFS and MapReduce, so this is the when I say it about HDFS, I will only consider name node and data nodes and secondary name node. And when I talk about MapReduce architecture, I talk about I will say these keywords on resource manager and node manager. Yeah. Now we will see on high level what are all the other components that will be typically involved in any Hadoop ecosystem. Ecosystem means it's a combination of the other tools also into Hadoop. Okay, the primary component that we need, the mandatory thing that we need is a HDFS to store something into your the HDFS. Okay, to store any data sets, you need this HDFS. HDFS is nothing but Hadoop distributed file system. This is responsible for splitting that 1 TB into 4 machines into equal parts. Okay. So the next one, if you have now you have the data stored inside your HDFS, and if you have to perform a select query and you want to retrieve a particular keyword, how many times it occurred, so then you should have a processing framework on top of it. Otherwise, you cannot search it. You can only search. You can only store with help of HDFS. You cannot process that data with HDFS. So that's why Yahoo came up with another framework called MapReduce, and Yarn is another generalized framework under which this MapReduce runs. Okay, Yarn is a generalized framework under which MapReduce runs, and there are some other tools they also run on top of Yarn. Okay, so as of now, it is just a motto of this demo is to give you the keywords that we use, and just to one word a description on each of these keywords. Okay, anyway, we have almost like 6 to 7 hours on HDFS and around 10 to 15 hours on MapReduce, and the remaining hours spent on the other tools as well. Okay, so yeah, as part of this entire 50 to 55 hours of training, you will cover all these different tools. Okay, and the Pig is another scripting language, which is, I can define it like a abstraction layer on top of MapReduce. You can almost achieve all the things that you can do in MapReduce, you can perform in Pig scripts, but there are some limitations that we will discuss them when we actually deal with the Pig scripting. Okay, so here something that can be written in MapReduce programming, mainly MapReduce programming, mainly written in Java. You can also write in other languages also, but if you need 100 lines of code to write in MapReduce, we can achieve that in Pig just by 10 lines. Okay, so that's the beauty of Pig scripting language. Okay, and there is one more data warehouse kind of tool inside Hadoop ecosystem, which gives you the feel of any regular DBMS. Okay, so you can store your data in terms of tables and databases. You can have your data structured and defined by columns and rows. Okay, so that even existing RDBMS organizations can migrate to Hadoop. And there is one more tabular database component inside the Hadoop, which we call it as a HBase. Okay, so this is of type NoSQL database. Even here you will have a databases and tables and rows and columns. Okay, so we will see what are the differences between Hive and HBase and how these differ from the traditional RDBMSs, and how will they give you better results and better storaging capacities when compared to these existing tools. Okay, And the fourth one, I mean, this one, this is the one of the most famous keyword that is recently getting evolved. Okay. So this keyword is getting more popular these days, and which is Spark. It will in near future, in another 2 years, it will replace MapReduce. In Hadoop, it's a dynamic framework. It's a set of tools. Every day, new tools will keep on adding. By the time you learn the current tool, you will market will have a new tool for you. Okay, you should ready for the next tool. So that's where you have to upgrade inside the Hadoop system. Okay, and the difference between Spark and the other MapReduce framework is that Spark will give you 100 times faster performance. Something which can be processed in 100 minutes in MapReduce can be processed only in 1 single minute inside Spark. Okay, but this is not completely matured, and people started using this, just exploring for POCs. I mean, 1 out of 100 companies also not having the Spark in production. Not even one company in 100. I can say it like a 1 out of 1,000 companies have Spark in production. Okay, but as part of our training, we are not covering the Spark, because for Spark is written in Scala, which is another programming language more advanced than Java. So since anyway we are also not covering the Java, because Java is like an ocean, I will only give you the basics. What are all the topics that you have to revise once again, and what are all the topics that you have to come by practicing. Okay, and there is another coordination service, so which combines these machines. Okay, so this is one of the backend daemon service that will be running on all our clusters. Okay, it will coordinate all these machines to form a cluster and to intercommunicate with each other. And anyway, from developer perspective, we rarely care about this. We rarely deal with this. Only this is a admin activity most of the times. And the other, there are 2 data ingestion tools. One is a Scoop, and the other one is Flume. And yeah, so there is a workflow manager or a job scheduler, I can say. And mainly when you are dealing with a HDFS 1 TB of dataset or 10 TB of datasets, you cannot expect your results to be within a fraction of seconds. Okay, it's almost like a batch oriented. You submit a query on via MapReduce framework or Pig or Hive. You can submit any query, and you have to wait at least for some seconds, something like 50 seconds, 1 minute or 2 minutes, sometimes even for 5 minutes you have to wait. So that means that is a batch oriented. So batch oriented means you can schedule your jobs to run at particular timings. Okay, one such a job scheduler is Oozie. Okay, and Falcon is another leveraging tool for Oozie. And all these tools, whatever these tools we have discussed till now, HDFS, Yarn, MapReduce, Pig, Hive, Spark, HBase, Zookeeper, Flume, Scoop, all these tools can be managed by these manager tools. These 2 are manager tools. Either Ambari, in Hortonworks we manage them through Ambari, in Cloudera we manage them through Cloudera Manager. Okay, suppose any of these services went down, either HDFS daemons went down, you can log in into your Cloudera Manager and you can restart all your services. And your MapReduce daemons went down, you can log in into your Cloudera Manager and you can restart them. And the same way with all other services as well. And the role of Scoop is it collects the data from any RDBMS, something like Oracle, Teradata, or MS SQL Server, DB2. You can pull the data into HDFS from RDBMS through the scoop tool. Okay, and if you have any web servers where you have a flat files or log files, those log files can be ingested into HDFS using Flume tool. Okay, using Flume as a tool, we can use that. Okay, so these are the just high-level overview of all the tools that this is the main, very typical Hadoop architecture. You can have lot many other tools also. There are around 200 tools are there currently in the Hadoop ecosystem. Okay, but majorly the core components are like HDFS MapReduce. You will definitely have HDFS and Yarn in any Hadoop cluster, and you will definitely have Hive and Pig also most of the times. And this Cloudera Manager or Ambari will also be there. And if you go with any commercial vendors, but HBase and Spark are optional. A few clusters may have these two, or they may not have. Okay, and out of these two also, even these might be sometimes optional. Some guys might be using them, or there are some other manual tools using which you can put your data into Hadoop. Okay, so either of, but the core components that you will definitely find in any Hadoop cluster are like HDFS, Yarn, Hive and Pig, and one of these Cloudera Manager or Ambari or Woozy will be there, and even the Zookeeper will be there. And apart from this, whatever we have shown in this architecture, you can have around lots of tools, and every organization choose on their own preference, on their own feasibility. They will go with their own tools, set of tools. Okay. So now, are you clear with whatever the roles of these tools? And are you ready to master all these tools? If you're yes, then you should have some pre skills that are needed for your Hadoop developer training. So mainly core Java programming skills are needed before starting for the training, and basic knowledge on SQL queries, select, create, and anyway, even if you don't have that, that doesn't make much difference. But the core Java skills are more strongly preferred, recommended. At least you should have a 1 week time to learn core Java skills. So that's why our actual batch will start from Wednesday, this 29th, morning 8 a.m. IST to 9:30 a.m. IST, 1.5 hour session. So before that, at least you have 3 more days. I would recommend you to go through core Java skills. What are the classes, what are the objects, and what is inheritance, what is inner classes, what are interfaces. Yeah, that much should be enough. And some of the string functions, string operations, and collections. Collections mainly lists, array lists, linked list, hash map, and sets. That much should be more than enough. But you should come at least by practicing 5 to 10 Java programs for the class. Otherwise, you can theoretically understand, but sometimes there might be some points that will be missing. Okay, and some other prerequisite for practicing Hadoop examples are like, you should have a laptop or desktop with a minimum of 8 GB RAM. Okay, it's a preferable to have 8 GB RAM with a Windows or Mac or Ubuntu CentOS, any of these operating systems. If you have Windows machine, we have to download VMware for that, and inside that we have to load this Cloudera Quick Start VM. So as part of this training, we try to use the Cloudera or Hortonworks Quick Start VM downloaded. In worst case, we go with the Apache parcels, Apache or CDH parcels. Okay, so I would recommend you guys to have 8 GB RAM laptops with you and download the Cloudera Quick Start VM, and I will you can easily Google it out. Okay, Cloudera Quick Start VM. You will definitely find a link there. And yeah, if it is through VMs, you need either VMware Workstation 8 version 8 or plus, or Oracle VirtualBox 4 or plus. If you download either Cloudera Quick Start VM or Hortonworks Quick Start VM, you should also have VMware Workstation or Oracle VirtualBox. Download the latest versions of these things, and the quick links for downloading them, like a download and install VMware Workstation 11 from this URL, and download Cloudera Quick Start VM 5.4 is the latest one. You can download from this link. And optionally, in worst case, if you don't have 8 GB RAM, then you can download Ubuntu 14.04, and you can install in a dual bootable mode. But I would strongly not recommend this, because that makes your setup complex, and even that I might not be able to support you all the time during the training, installing through parcels. But if you are very good enough in understanding the documentation and following the procedure, I have a very good documentation for this, for the third option. If you just have 4 GB RAM, and if you are fine with going dual bootable OS for Ubuntu, and download Ubuntu and install on your machine and follow the procedures, and I will, if there are any guys like that, I will show you links for each of these tools, how to set up, and I will give you the overview of setup instructions in 5 minutes or something on every tool that we come across. Okay. Yeah. Do you have any questions? Kashyap, Parthiban, Vijay.
Shiva, it's okay for me. No questions.
Okay. Okay. Yeah, you are clear, right?
Yeah, I'm good.
Okay. What about you, Kashyap? I think some keywords might look high level for you, because you're just having 2 years of experience in IT. And when I talk about EDW or some ETL tools or something, they might, looks like a new keywords for you. Might be. Okay. That, yeah, slowly you will get to know all these things. Okay, don't worry. But those are some of the common terminology that we use across the industry, right? So you have, you should be aware of them. You will slowly get to know all those things. Okay. What about you, Parthiban?
Core Java.
Parthiban, I think you are on mute. I didn't hear you.
Yeah. Are you hearing me?
Yeah, I can hear you now.
Yeah. Okay. Other than Core Java, I'm ready with everything. I can understand fully.
Okay. Yeah, then what I will do is, in my first session, I will share the Core Java PDF with you, and I will specify what are all the chapters you have to focus. Okay. So from there, yeah, you can start with it. Okay. Meanwhile, either from Java T point or tutorials point or something, keep practicing some of the examples. Okay.
Yeah. Okay.
Yeah, I would strongly recommend you to first learn Java skills, at least basic Java skills. You don't need advanced skills. Advanced Java is not needed. Only what are the classes, inheritance, and collections should be more than enough. Okay. If you if you can spend at least 20 hours for Java, that should be more than enough. Okay, and even I will spend around almost like 4 hours in giving you overview of these all Java concepts. Anyway, I will give you the overview of all the Java concepts, but don't depend completely on that. Okay. Yeah, and okay. So yeah, we will start our actual batch from Wednesday, this 29th, morning 8 a.m. IST. So before that, you have to register for your training, actual training, whether you are willing to start from the batch or not. Okay. So either you can send me your email. So and before that, you have to make your payment, at least a nominal fee, and after that, you within a first week of the batch starts, you have to make the remaining payment. Okay, so for you guys, Kashyap and Parthiban, I mean, if you are interested, just let me know in your email. I will share the account details for you.
Yeah.
Okay, just let me know if you are interested. Okay.
Yeah, sure.
Okay, guys. Yeah. Bye bye. I will be sending you mails. You can share your interest by end of day.
Okay, sure.
Yeah. Okay, guys. Yep. Bye bye.
Sure.
Yeah, Vijay.
Yeah, can you please share this recording? Keep it, please.
This recording session.
Yeah.
Okay, I will share it with you.
Yeah, thank you.
Okay.
Thank you very much. Thank you.
Yeah. Thank you very much. Bye bye.